National Space Biomedical Research Institute is a nonprofit organization that's been working with NASA for the last 17 years. It has partnered with NASA to address the major health risks to astronauts in space. So astronauts have developed a syndrome called visual impairment and intracranial pressure. We're seeing some concerning changes in their eyes and their vision, and we believe that it has to do with increased pressure on the brain. We think that there are certain conditions in spaceflight that actually cause this pressure on the brain. For example, the fluid shifts that occur in the absence of gravity. We know that astronauts develop this puffy face where there's a lot of fluids that move up towards the head. We see it in pictures when they go up into space. They have a lot of buildup of fluids here. They can't smell well. They complain that they have a lot of congestion. And so we know that there's this fluid shift, and we think that that might contribute to the pressure on the brain problem, which could be causing these visual issues. The other concern we have is in space we are not currently able to, with an engineering solution, decrease the carbon dioxide levels to those of atmospheric levels. They're roughly on average about 10 to 20-fold over normal. So carbon dioxide elevation over a long period of time, they're spending months in space, and now we have a one-year mission. We know that that could be a toxin. We know that carbon dioxide elevation is not good for you to have over a long period of time, and we also know that that can affect the brain. And so we're wondering whether the combination of the fluid shifts with microgravity and the carbon dioxide together are causing changes in the brain that could be leading to an increase in pressure, that could be causing some of the visual problems that they're seeing because the eye is connected to the brain. So the problem is it's very difficult to test astronauts with all kinds of imaging. We can't do MRIs in space, we can't do CT scans, and by the time they come back, they're no longer exposed. And so in order to study it, we can try to simulate some of the space conditions here on Earth. And so that's what NVHAB is able to do, is to allow us to test some of the fluid shifts and also the carbon dioxide elevation, what effects those have on the brain and the eye structure. So to be able to tease out this problem, because if we can answer what's causing this, then we can start to mitigate the problem and actually reduce the CO2, or to give them some way to alleviate the fluid shifts to the head. NSBRI is really very happy to work together with the DLR and the Institute of Aerospace Medicine. We funded this study, and it's a first of its kind. The key here is an international group. Doing the experiments and answering questions about spaceflight is so challenging and so difficult and so expensive that you really need to use the positive aspects of everybody, the expertise of all the groups, in order to answer these complex questions. Just like the International Space Station requires many partners and many expertise from all over, doctors, engineers, scientists, physicians, physicists. We have all these people coming together. This team is a multinational, multidisciplinary team, and we're bringing some very cutting-edge devices which we believe can really change not only what we're studying in space by taking these very unique devices that can measure brain physiology in a new way, not the traditional way, but we can also impact patients' care on Earth. So some of these devices that we're testing in this study could help some of these physicians that we brought here treat their patients better and understand better what's happening when a patient has a brain injury or when a patient has too much fluid in the head. It can also help them treat those patients. We're all very excited about what we can learn from these experiments to help both manned spaceflight but also patients here on Earth.